Hello students, welcome to EDUHUNT online video classes. In the previous session we have discussed the concept. Now we are going to solve few questions based on that previous concept. That is challenging problems too. Okay. Let's see the very first question. The number of twin primes between 200 and 300. Here we should know what is a twin prime number. So twin prime numbers we should know. So what are twin prime numbers? The difference must be 2 in between two prime numbers. Those prime numbers are called twin prime numbers. Between 200 and 300. If we take this table, these are prime numbers. These are prime numbers. The difference must be 2. The difference is not 2, that is more than 2 here. And if I take these two numbers, I will get difference 2. Here I will get difference 2. So that is 1 I can write, and difference is more than 2 and difference is only 1 here. Here difference is more than 2 and here difference is 2. That means first combination is 227 and 229 and second combination is 239 and 241. These are twin prime numbers. These are also twin prime numbers. Next is difference is more than 2. Difference is more than 2 and difference is more than 2. Difference is more than 2 and here 269 and 271. These are twin prime numbers. And these are not twin prime numbers. Again, these are also not twin prime numbers, but here 281 and 283, these are twin prime numbers. Difference is more than 2, so therefore these two are not twin prime numbers. Here how many pairs we got? 4 pairs we got. Okay, this is the answer for that question. For this question, twin prime numbers, how many pairs? I got 4 pairs only. Okay, let's move on to the next one. The number of prime numbers between 110 and 190. Here we should know prime numbers between 110 and 190. Let's check this. 110 and 190. Here 110 is there. From here to 190. From here. Okay, how many numbers are there in between them? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, only 13 numbers we got. Okay, right. So how many numbers? The prime numbers between 110 and 190 are 13. Okay, let's move on to the next one. If A equal to 24, B equal to 36, C equal to 12, then the number of factors for C square into B minus A whole square is. This question, in this question, we should find first we should find C square into B minus A whole square. First substitute the values what are given in the question, that is 12 square into B minus A, 36 minus 24 whole square. Okay. 12 square is nothing but 144 into 36 minus 24, that is 12 square. Again 144 into 144. This should be written in the form of exponents. Now we can find the number of factors. 144, this 144 into 144. These two can be written 12 into 12 into 12 into 12. So this 12 can be written 3 into 2 into 2. How many 12s are there? 1, 2, 3, 4 12s are there. That means 3 power 4, here 4, here 4. Okay, this can be written 2 power 8 into 3 power 4. Now to find the number of factors, we should take the exponents and add 1 and we then multiply. That means 4 plus 1 into 8 plus 1. That is 5 into 9, 45 is the answer for this question. Let's move on to the next one. If A and B are the smallest even composite and odd composite numbers, then A plus B into B minus A is a factor of smallest even composite is 4. Smallest odd composite number is 9. Then A plus B into B minus A. A plus B into B minus A. That is 13 into 5. Okay. So every factor means that is a divisor. Okay. Divisor. This, if it is the answer, this should be divided by this one. If it is the answer, this should be divided by the answer. If it is divided by this answer, if it is divided by this answer. Now check this. First take 5 table in simple manner. So all the numbers are divided by 5 because unit digit is 0. Now check with the 13 table. Okay. 13 3s 39, again 13 1s 0, 13 1s 13 0. So now answer for this question is 4030. Okay, right. Let's move on to the next one. If the sum of prime numbers between 3 and 50 is subtracted from the sum of all prime numbers between 50 and 80, then the resultant value is the sum of prime numbers between 3 and 50. 3 and 50. Here 3 and 50. What? Let's check. 3 and 50, in between 3 and 50. That means, see, let's see the question again. Between 3 and 50, that means we should exclude 3 and 50 both. That means 1, 5 plus 7, 12, 12 plus 5, 7, 12, 3 and 50. Where is 50? Till here. Okay, right. 11, sorry, 5, 7, 11, 13, 17, 19 and 23, 29, 31, 37, 41, 43, 43, 47. Okay. Now we should add all these numbers. We should find the sum of these numbers. Okay. This is 20. Let's do like this. 1, 2, 3, 4. 40. 40 plus 20, 60, 80. 110. 140, 180, 220, 260. This is 260. Now add unit digits. 10, 10, 10, 1, 2, 3, 30, 40, 50, 57, 62 plus 1, 63. That is 3, 12, 323. So this is 323. This sum is 323. Now the sum of all prime numbers between 50 and 80. 50 and 80. That means 53. Let's see here. 53, 59, 61, 67, 71, 73, 79. We should add all these. 100, 160, 100, 50 plus 50, 100, 160, 160 plus 60, 220, 220 plus 210. that is 430. This is 430. 440, 450, 460, 463. Okay. Now this sum is 463. This sum is 463. Okay. If the sum of prime numbers is subtracted from this sum, okay. So now 463 minus 323. 323. That means 0, 4, 1. 140. Now this 140 is multiple of. Yes, multiple of 7. Yes, it is divided by 7. Multiple of 3. No. And multiple of 9. 9 table we should not get. Okay. Yes. So answer for this question is A. In this manner only we have to solve this type of questions. Okay. Let's move on to the next one. If there are A prime numbers and B composite numbers between 20 and 40, then A plus B equal to A prime numbers between 20 and 40. This is 20 and this is 40. Okay, right. A prime numbers, B composite numbers. A prime numbers. How many prime numbers are there? 1, 2, 3, 4. A equal to 4. B equal to B equal to the number of composite numbers between 20 and 40. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15. Now what we have to find? A plus B. A plus B is nothing but 19. Now answer for this question is 19. Okay. Let's move on to the next one. A, B, C, D and E are consecutive prime numbers, then C into E minus A, B, C, D are consecutive prime numbers. Let's take 2, 3, 5, 7, 11. Let's check with the example. C into, that means 5 into E minus A, 11 minus 2 into D minus B, 7 minus 3. This is 4, this is 9, this is 5. First we should multiply. If you see any 5 and even number, just first we should multiply them. 5 4s 20, 20 into 9, 180. So answer for this question is 180. If 180 is not there, then any multiple of 180 is the answer for this question. Okay, let's move on to the next one. If 60 is a composite number, then it is a multiple of. 60 is a composite number. The only odd prime. So only what is only odd prime? It can be divisible by 5. 7. Odd primes means 5, 7, 11. These all are odd primes. It is a multiple of 5 but not 7 but not 11. Okay, answer for this question is not at all A. And the only even prime, even prime is 2. It is divisible by 2. Next, all prime numbers, it is divisible by 5, 2 but 3 and but not 7 and 11. That means this option is also wrong. All composite numbers 60. Let us take 8. So in 8 table 60 will not come, so it is not divisible by 8. Therefore answer for this question is the only prime number, even prime number. Okay, let's move on to the next one. A and B are twin primes and P and Q are even composite. Let's take A is 3 and B is 5. Here it is A and here it is B. P and Q are even composite numbers. P, Q. 4, 6. Okay. Now P plus Q. What is P plus Q? Is 10. And B minus A. B minus A means 2. 2 ones, 2 5s. Now the remainder is 0 here. Okay. Answer for this question is 0. Okay. Right. In this session we have discussed the challenging problems too. In the next session we are going to talk about few concepts and then we solve questions. Okay. Until then, see you. Take care. Bye bye. Thank you.